Thank you very much, Tim. Bear with me here. I'm just trying to get
Sure,
my
no problem.
PowerPoint to show. Let me share the
I'll watch
screen.
Q&A in the window for you, Jack. And
Thank you. I appreciate that.
sure. And I'm going to mute
One
myself.
of the things I will do too, I've got a couple things open. I'm probably going to go off of video, just uh, just to make sure you're focused on what we're
Absolutely
covering
fine.
here.
Sure thing.
And hopefully everybody can now see my screen. For it should say Azure Machine Learning. Um, To give you an idea, I'm a cloud solution architect. I do not claim to be a data scientist. I consider myself more of a data engineer, and I make the joke I stayed at a Holiday Inn Express last night. Have been working with the machine learning tools for quite a while, and have also been following along where the trend is going with machine learning. Because to me, I think one of the big things about machine learning is that in reality, there just aren't enough data scientists out there in the world. Um, and so the only way that machine learning is really going to take off is to make sure that we can democratize it. Like, how do we make it easier for those of us that are data engineers and that don't have a PhD in data science? So I'll walk you through some of the pieces here as well. Just some etiquette pieces too. Bear with me here. One of the things that we ask is that you mute yourselves. If you are not presenting, which means, i.e., you're not me or Tim, please make sure you're on mute to minimize the disruptions. So like what we were talking about, machine learning, what is it? So this is actually machine learning v3 for Microsoft, and there's kind of the joke by version 3 we get it right. So version 1 we came out really with what was called the original Studio, which was a designer, which was a drag and drop tool, had some really neat stuff to it, but a lot of the data scientists said, that's more of a toy. It's not a tool. We need something that is a little stronger. So we started to shift, and we went to machine learning workbench, which was more Python notebook based. And what we ran into is we had people telling us that you've now shifted the other way. It's no longer democratization. So then we've come back and now come out with machine learning workspace, which incorporates Studio. Yeah, that's a little tricky, but it also has a lot of other pieces to it as well. And one of the things that you'll see anytime you're going to do some machine learning within um, machine learning, you're going to prepare your data, you're going to run your experiments, and you're going to deploy them. So the big thing is you're going to do some data wrangling, you're going to build out, test, and train your model, you're going to register it, and then deploy it out to a web service. What I really like about the machine learning workspace and Microsoft Machine Learning Service now is I don't have to do it within the browser, within the workspace. I can run my own Jupyter notebooks in the cloud. I can run Anaconda locally on my machine. I can run it in Visual Studio Code locally on my machine and publish it up to the workspace. And so we'll talk a little bit about that as well in some of those pieces. But the biggest thing to understand here is just what is there for the Azure Machine Learning, the ML components. So within the workspace itself, it's going to have a lot of pieces to it. So the first thing you're going to have is you're going to have your user roles. So you can set up specific user roles that are different than RBAC security in Azure. You have compute targets, and it looks like there's a lot there, but quite honestly, most of the time you're using the Azure Machine Learning compute. If you don't want to use that, you can use other compute targets. You can run local compute on your machine. You can use a data science VM. There's a lot of pieces to it. When you spin up a machine learning workspace, it's also going to spin up in that resource group a storage account, Azure Container Registry, and that's for model deployment, Key Vault, and some app insights. And then when you run your experiments, you'll have pipelines. And so pipelines now allows you to do things in automated fashion that you can call out and have a couple things happen. It's also how you can do ML ops, which is DevOps, your continuous integration, continuous deployment, your CI/CD pipelines. You have your data sets. So we're going out and we're grabbing data that's out there. There's models that we're going to register, and then deploy them. And that's really where machine learning becomes important, is how can other services consume that web or that model that you built. And I'll show you that with an example today of Power BI, but it doesn't have to be just Power BI. Again, we're going to deploy out a web service endpoint that you can then have other services consume. So to me, that's always important. So there is the ML Studio. And instead of actually showing it to you on a PowerPoint, because I really don't want to do death by PowerPoint here, we're going to go right into Machine Learning Studio. So when I come into Studio, there's three areas that you author. There's Automated ML. Bear with me here. There's Automated ML. There is Designer, and there are notebooks. Also, your assets here. So your data sets, like where am I grabbing my data from? I can run my experiments. We'll talk about the modules, the models, and then the endpoints are also key as well. So with endpoints, this is what I use, that I'll use today to call out a specific service. So if I was to actually click on this endpoint, it'll show me some of the connection detail within there. You know, there's my REST endpoint that I can use. It's am I doing anything with regards to authentication, token-based authentication? So it gives you some details. So this is really the kind of the finish line. What you're doing with machine learning is I'm publishing out this endpoint that other areas can consume. And again, anytime you spin up machine learning, you have it tied to a compute instance. So here's my compute instance here. If I was to create a new compute instance, it's very much just like a VM where I can specify, am I doing CPU, GPU, think about turbocharged. I'm really trying to do something pretty heavy. And I can pick what I need for my GPU and so forth. Now, again, with compute instances, you're not spinning up, this doesn't typically consume a lot of consumed revenue. You know, this isn't running the meter. It's when you start getting into some of the other areas that it does. There's compute clusters that you can use, and you use these to run experiments themselves. You have inference clusters. So this is really here where if I'm going to spin out or publish a model to an endpoint, I'm using an AKS cluster within there. And then if I want to do anything with attached compute, I can attach a VM and so forth. This is my mad scientist lab, so you can see some things go well, some things don't. And then also we'll talk a little bit about some of the other areas like data stores, data labeling, and so forth. But what I'm going to do is I'm going to just come back to my presentation. And let's talk a little bit about the data science platform here that we have. So again, with machine learning, like I was saying, is some of the development tools that you have here. You have Jupyter. You can use Visual Studio Code. The languages, we support Python and R. I would say probably about 4 years ago, it was almost 50-50 Python and R. And now I'm really seeing most of the work is really being done in Python. There is still some R out there. We support both, but where we're seeing the trend to go is really Python. R is usually more some of the traditional people that use statistics and so forth. But again, it's flexible. You can do both. I'll show you that in notebooks. I am not a Python aficionado at all. I can cut and paste with the best of them. So that's where I really like Designer and AutoML, which we'll jump into. And then some of the frameworks that are out there. Onyx is kind of the big one right now. It's kind of cross-platform consortium with Facebook and a few others so that I can build something and have it work on a couple different areas. So let's talk a little bit about AutoML and what it means. So this slide here talks about, okay, I have a machine learning scenario. What am I trying to do? Am I trying to do text analytics regression? Am I doing anomaly detection? You know, is it a classification? Do I have something that is unexpected as opposed to expected? Am I doing some more two-class classification, multi-class? You look at this, people start running for the hills. So sometimes you have a data set, and really all you know is there's 3 different classifications we want you to know. Is it, you know, like, is it a classification? Meaning, do I expect failure or not? You know, it's just kind of a 0 or 1 binary scenario. Regression, meaning that I'm going to take a couple factors into play and see if I can do some prediction based on that. And then time series. So if you can classify it into one of those three, you don't necessarily have to worry about this here for AutoML. And what AutoML allows you to do is really just take some data, we can apply some features and some algorithms to it, and it can tell us, well, it ran all of these experiments, it thinks this is the best model for your data set, and we'll actually explain why it does that too. A great example, one of the companies I work with, they do a lot in aviation. They had a data set. They had a pretty good idea of what they were looking to do with regards to classification, but they threw some AutoML at it just to get a head start to see if that was the best way to go. So,
Hey, Jack,
yes,
is I think a couple of people are having trouble seeing the slide. The slide that you're showing right now says automated ML at the top, has
correct.
the little icon at the far right.
Yes.
If you're on the line and you can't see anything, I would exit out of Teams and come back in. That's probably the best way. Sorry to interrupt, Jack.
No, that's fine. That's fine. Um, so with automated ML, again, like what I really like about this is you can you just bring your data set, and then from that we can start doing some quick exploration of that data. And again, it's not something that you have to be a data scientist on. If you're more of a data engineer and you know your data and you want to start to see what you can do with some of the machine learning algorithms out there, and you know how to do Google or Bing searches, well, then that's going to help you as well. And I'll talk a little bit about that. So the biggest thing, again, when you do automated ML, there's three different types. There's classification. Again, they're like the example, like yes, no, is it blue, red, green? A lot of times what you'll see in some of the Microsoft Learn examples is they do penguins. There's three types of penguins. And I'm not going to remember the type of the penguins offhand, but it basically walks you through that if you have certain characteristics on a bill or beak of the penguin, we can figure out what it is. Regression, that's what we're going to do for the example I'll show you, which is we're going to predict how many bike rentals based on weather, based on what time of year it is, which day of the week it is it a holiday or not? And then time series forecast. So just doing some prediction based on timing. So what happens with automated ML is it's going to give you a bunch of different scores. So for this one here, it ran all of these experiments. And what happened is it actually grabbed here when it was looking at the data and said, I'm going to do a Spearman correlation. In a Spearman correlation, the higher the score, the better the experiment did. And that's what I was joking about doing internet searches, whether you're doing Google or Bing, is sometimes you'll just do a quick search on, okay, tell me a little bit about Spearman correlation. Tell me if I got a good one. Tell me if I got a bad one. Because some of the other measures that you'll use, it's the opposite. The closer to zero is the better. And in fact, the one I'll use will show you that. So you have that ability to do that. Pretty simple. So again, for this example, we can see the max abscaler decision tree did the best. So let's actually jump into machine learning workspace, and I'll show you a little bit of a demo here. And what I'm going to do is we'll run one through, and then I'll show you the same one that I did yesterday, because AutoML can take some time. It can take 15, 20 minutes. Within here, like I said, we're going to do some prediction of bike rentals. And this is the data set that we have. So what season is it? Is it spring, summer, fall, or winter? Is it a holiday? Is it a weekday? Is it a working day? What is the forecast? What's the temperature and so forth? Because sometimes you look at it and go, well, wouldn't bike rentals just be based on temperature? And I'm up in New England in the Boston area, and if it's January and it's 60 degrees, but there's still a bunch of snow on the sidewalks and the road, you might not get a lot of bike rentals. However, if it's 60 degrees in May and it is a holiday, you might get a lot of bike rentals. And then figuring out wind speed and so other things like that. So we'll start to take a look at this data here, and let's do that. Let's jump in to my machine learning workspace. So what I'm going to do here is I'm going to come in along the left blade here. I've got automated ML. So I'm just going to go ahead and pick on AutoML here And I'm just going to minimize this blade so I can maximize the window within here. Now, for this, I can see these are a couple runs that have already happened. And this is the one we'll investigate that happened yesterday. And it's going to be the same thing that we're doing today. So I'm going to go ahead and click New Automated ML Run. And the first thing it does is it says, okay, what is your data set that you brought to this? And again, you can create your data set right here, brand new from local files from a data store from like an open web. It could be an open data set that's out there on the web as well. So here I'm actually going to use one of the data sets within here, and I'm just going to sort, and I can see bike rentals. And I'm going to select that, and I can even explore that data set a little further. So when I click into bike rentals, and I know we looked at it, I showed it to you on the PowerPoint, but now I want to show it to you live within Azure Machine Learning. So now I can see how my data comes across, what day, what month, year, season, holiday, and so forth. And now I can even go into data statistics. So it can start to tell me a little bit about my data. So it starts to analyze the data. One of the tricks with machine learning is sometimes you got to do a little data wrangling to get rid of the outliers, because you don't want the outliers skewing your model development within there, because maybe that's not something that typically happens. So, well, which would be an outlier. So you can now start to see within here, am I missing any data? Do I have any empty data? Is there anything I need to do for data correction? What's the mean? What's the standard deviation on some of this data? Some of this data might have a very high standard deviation. And then that's where you got to look at it and go, was that expected? Should I have a high standard deviation? Well, for rentals, okay, that makes sense. Sometimes we do a lot of rentals, sometimes we don't. So again, it's a good way that you can just quickly examine your data within here. And I'll go ahead and click close. So now that I picked that data set, I'm going to go ahead and I'm going to click next. Now with that, it's going to give me some options here to start configuring the run within, and I can see, do I want to create a new experiment? Do I want to, grab an existing experiment? I can actually use an existing experiment, and an experiment helps you with the run. But if I wanted to create a new one, I could, but I've already got an MS Learn bike rental example in here. What's my target column? This is basically, what am I trying to predict? Well, I'm trying to predict rentals, because maybe there's a lot of effort that goes to getting bikes out and available and being ready to rent. And if I think it's going to be a low prediction day, why spend the time and resources to get all the bikes throughout the city? Now I've got to pick my compute cluster. So again, this is what is the horsepower behind there. So there's my cluster to run the experiment within there. And I can always create a new one from here if I wanted to. So again, we're just gonna, if you're creating an experiment, it just is an example of a run, and you'll be able to see those off to the side here once we're done. So again, my target column, let's figure out what we're trying to predict. And now, what are we doing here? Are we doing a classification? Are we doing a regression? For this example, we're going to do a regression, and we're going to look at some additional configurations. So the big thing here as we look at this information here for the regression is my primary metric is normalized root mean square error. So you've got a couple examples within here. And again, this is where it'll start to talk about that information. You can click on the links and it'll give you more information about that. So that may be where you have to do a little research just to understand it. But with this, the way normalized root mean squared error works is the closer to zero, the better. I can even have it do some explanations for me. I can say there's certain algorithms that I don't want to run. For the sake of time here, I'm going to go ahead and only run random forest and light GBMs. And again, we have explanations on what those are as well. So as you go in, there's a whole setting that talks about algorithms, what they do, how you can work with them, and so forth. And I'm looking to see, I've got some links I can throw in the window too. Exit criteria. So this is kind of cool. I can say, well, stop running after an hour. For this one here, I could say stop running after, I'll go a half hour if it keeps going. If I reach a certain metric threshold, meaning that, again, I know the closer to zero, the better. If I can get it down to 0.08, I can stop the experimentation. I've found a model that'll work for me. I don't have to set it that way if I don't want to. And then for the rest of the settings, I'm going to leave default with regards to model concurrency, or excuse me, validation and concurrency. So I'll go ahead and click Save there. And then I also have some featurization settings. So featurization is now when I start to go into looking at this data and is there something I need to do with the data, meaning that if I'm missing values, what should I insert there? If I don't have a day of the week, should I figure out the main, the most frequent, the median? Should I put in a constant or anything? I'm going to leave this auto because I'm just doing AutoML within here. And I'll go ahead and click Save. Now with that, I'll go ahead and finish up this experiment here. So I'm going to go ahead and just click Finish. It's going to start creating a brand new automated ML run. And now here's where I can start to, I'm going to go ahead and I can see how it's moving along within here. But what I'm going to do is I'm going to expand out this area again, and I'm going to come into automated ML, and it's going to show me, okay, this is what's running now, but here's what I ran yesterday. So let's take a look at what I ran yesterday and look at this run of 383. So the first thing I can do is I can see that it completed, how long it took, the compute cluster, some of the run IDs, some of the other information. But also I can see what it said did the best. I can see that it said the max abscaler algorithm did the best within here. And if I want to, I could click on this. It'll give me some of the details within there to see that information. But I'm actually going to go back one here to where I was, and I'm going to jump out to my models area. So this shows me everything. This shows me how they all ranked with the models that it ran. So I can see this was definitely the best scoring model within here, and I can drill into that. Also with data guardrails, I like this feature. It tells me how did we do with our data? How clean was our data? And then what were we able to do with that information? But let's jump into the models here, and let's actually get an explanation of what it saw with the max abscaler. So I'm going to go ahead and click on the explanations, and I've got an explanation ID. I'll click on this within here. It'll start to show me some of the information within. I'm going to go into metrics. I like looking at the metrics. So it told me what was the variance, was the mean absolute error, the absolute percentage. But these are kind of nice, but I'm going to deselect these. I'm going to go for predicted true and residuals. So now what this does is this actually shows me the average predicted value and what the ideal value is. So the closer these are together, the better my experiment is. So I can see I'm pretty darn close, and that's my 0.08, so forth. So as you run through some of the experiments, some of the ones that did worse, they deviate further out, and I can see some of this information. Now for outputs and logs, here's what I really start to like about this. If you're a hardcore developer, you want to write in Python, you want to go a little further, you can download the pickle file for that model, and you can start playing around with that in Python and other areas to your heart's content. Here's the scoring file as well. Do I want to grab the scoring files? I can see that information. Any of the environmental files. So if there's other things I want to do with this automated ML experiment, I have the ability to do that now and export them out and use them in different ways. Now I can, if I like this model a lot, I can deploy it to an endpoint. So I could put this in an AKS instance. I could throw it in an Azure container instance. Most of the time, you're probably going to be using AKS just because Azure container instances usually don't have the horsepower for a production model. They're great for dev and test. But now you could actually publish it out and have other services consume this. And I'll show an example of that when we now jump into the designer. But again, the idea of this now is if I wanted to test this is, okay, I could take some information, a day of the week, temperature, time, so forth, and it can start to do prediction on bike rentals for me. So this is just an easy way to be able to publish out a model and be able to start to test that model as well to see what it does for you. So I don't know if I have one. I got a lot of diabetes stuff. Let's see what I got for endpoints. I don't know if I got a bike rentals. I do have a bike rentals one. I have not worked with this one in a while, but you can see here's some of the information within it. And then sometimes what you'll actually have is, yeah, so it's not active now. If it's active, I can actually test against it, which is kind of neat to see. So to give you an example of the AKS one that we're going to use within here, I can actually test that model, meaning I can put in some date. So I could say like Accelerometer Y. I go to test this, it would tell me, did I get, what was my score? So this one's classification. So this one's telling me it's normal. If I did something like 500, 500, negative 600, test that. Oh, somewhere in that range, I'll actually start to get a 0. Let me see here if I've got one. Oh, I do. Let me try. 3, 591. That's a negative 553. I test that. What do I get? Yep, so now I got an anomaly. And I'll explain a little bit about this more. But again, this is a way that you can start to test out those models once they're active. You can consume it via the REST endpoint. Here's also some information for C. It's from Python information if you want to bring it in and so forth like that, and R. So some great stuff there within. So for automated ML, again, the idea is I've got data, as one of my customers says, we got a data set, we're going to throw it against the wall and see what sticks and what model actually helps us. So by deploying out that model and then sending some of your bike rental data through there, you can start to predict rentals based on season, holiday, weekday, workday, and so forth. Oh, there was actually one thing I totally forgot to show you that is one of my favorites if I'm looking at automated ML. Actually, hey, the one today finished pretty quick. Let's see what it did. And, oh, it's still running, so it didn't finish. My bad. Within here, if I go into automated ML and I look at run 383, and we were looking at some of the algorithm data here. Was it under data transformations? I get into explanations. It might be here. There's one that's pretty cool that talks about aggregate feature importance. What this means is this was actually your biggest influencer on rentals. So out of the features are your input values. So this told me that working day was actually the most influential. It wasn't temperature, it was working day. So if you got a favorable temperature and it was probably a weekend, you're going to have high bike rentals as opposed to what year and humidity. And then year is kind of interesting because that's where you're going to look at your data set. I might look at this and go, data set I had started in November and ran through July. Well, chances are let's say it started in November of 2020 and ran through July of 2021. Well, 2021 might be better because you got warmer months. So again, that's understanding your data and so forth. But so it's kind of neat to play around with automated ML. There are some good examples out there on Microsoft Learn. I'll show you a link as well, so you can start to see that. The next thing here, I want to go a little. We're going to go a little further in is what I'll call is the designer. So this is the drag and drop feature when Azure Machine Learning Studio first came out a couple years ago. It's basically that feature here. So now I have the ability to drag and drop information onto a canvas and start to do some basic machine learning. Again, if I don't know Python, I don't know R that well, I can use the drag and drop functionality. Cool thing is you can even drag in and drop Python code or R code here too. And again, here's just kind of some examples of how the designer works. We're going to have a little fun with this because I think a live demo actually helps so you can understand what's going on with the designer. And this is where you do need to know this example. So what I'm actually going to try and do is do an anomaly detection. What I have on my desk, bear with me here. All right, you're looking at my live phone. What I actually have on my desk is an MX chip. And what this MX chip does is it's kind of like I think about it like a built-in Raspberry Pi for Azure that's already got some built-in sensors for me. So I've got temperature, I've got humidity, I've got magnetometer. Accelerometer is the big one that we're going to look at here. Accelerometer is like which way is this is the MX chip facing here. So when you use your cell phone, accelerometer is what figures out do I go to portrait, do I go to landscape. I always make the joke, accelerometers, your friends at last call, are they up, do they fall down, or so forth. But we're going to figure out what's normal, and the way that you do that is you have a training data set to tell you what it assumes is normal. Normal, I assume, is this thing sitting on my desk. Abnormal is some other way that it's actually going right now. And we'll use the designer to build out that model. We'll publish the endpoint, and we'll have Power BI consume it so that you can see that within there. And I'm going to go ahead and minimize that within here. So knowing that, we're going to look at anomaly detection. And what that means is for the anomaly detection here, I've got to pick one of these two. Because I need to know, is it normal, is it abnormal? And I'm just going to do the PCA-based anomaly. And what this gives me here is, some fast training times. I don't know too much about anomaly detection, but I can start to work with it. So for that demo, like we said, we're going to predict anomalies, accelerometer readings. So these are Y, that's Z, that's X. So there's 3 different accelerometer readings that you get. So again, for a cell phone, that's what helps you figure out if you're in landscape or portrait mode. Like I showed, that's normal. For my training set that I have trained against how my MX chip orientation is, it's sitting flat on a desk. This is not normal, and you can see my high-tech holder here. It's on an angle. It's kind of bent. That's not a good thing. So one of the things that we're going to do here is the way this works from an Azure standpoint is the MX chip sends data to IoT Hub. I have a stream analytics job that sends that information to Data Lake. Data Lake then is read by Synapse SQL on demand. And what happens is what Synapse SQL on demand is doing here is, as it reads against this data lake, it's basically saying, do a select statement against any CSV that sits in this location within here. So I can dump a bunch of CSVs, and it's actually Stream Analytics that's doing it for me. And from that, I can start to read that data like I would in any SQL database within here. So this, as far as it just kind of looks like SQL as I do this. Now, so as that data sits here, I'm going to create a machine learning model. And what I'm going to do is when I train that model, it's going to read off the data lake. So it's going to figure out, okay, what's normal and abnormal based on the data I provided it. So I really want to try to provide it a bunch of normal readings and a tiny little sliver subset of abnormal readings. If you don't give it abnormal readings, it doesn't know what's abnormal. So that's something to understand. I'm going to validate that, and then I'm going to deploy that model out to an AKS cluster. And you saw that where I tested one of the models earlier to figure out was it normal, abnormal. Power BI is going to read off of the Synapse data, and then it's going to run that data through the model, and we're going to get a result back to tell us, did we get a normal reading or an abnormal? Abnormal is 1. So within here, if I look at this data here, these are abnormal readings because the orientation that I had the chip going. So let's go ahead, and with that, I'm going to go ahead and start to run this through the designer. So let's show you what the designer looks like. I'm going to go into the designer, and what I've got is I've got a training model called IoT Train. Just like I was talking about before, where you can do a lot of the drag and drops within here. This training model, what I did is I imported data. And when I import data, I grabbed it from a data store. So think of it very much like a linked service, if you're familiar with Azure Data Factory or Synapse, where I'm going out and reading against that data store. And I'm saying that anything in that data store, I want to pull into this model. Then I'm going to split the data. So with machine learning, it's something that you learn with machine learning is I'm going to take some data to train, and then I'm going to take another subset of that to score against that training model. So I want to see how my model actually did. So typically you take 70% of your data to train, and then you take another 30% to score against. And then when I'm training, I'm using that PCA-based anomaly detection. And again, you can go out and do a Google or Bing search on Azure Machine Learning and Designer and some of the models that are out there. And we'll make sure that you have some of that information too. So then what happens with that is once you've got it to where you can score the model, now you can update your inference pipeline. Is it a real-time pipeline? Is it a batch? So for this, because my MX chip is sending data pretty regularly here, it's real time. Like it's sending that data, as much as possible. As you can see, it's about every 4 or 5 seconds it's sending out that data. So knowing that, one of the things I'm going to start doing is, let's see if I get this right. I'm going to hold the chip like this, and then see if we get some good anomalous readings. So I'm going to look at my real time. Now, what happens with real time inferencing is what happens is you have the data set that came off of these trained models. This web service is the fact that I'm holding my my MX chip up. This is the data coming in against the scored model and giving me an output. So then how does this all work? Well, let's actually take a look at IoT Explorer. So let's see how I'm doing holding my chip here. See, these are my accelerometer readings, so I'm pretty good there. So we'll see this will update about every, 5 or 6 seconds. So I'll get another reading that'll come across. So this is where I started holding the chip up. Let's go down a little. This is probably before I was holding the chip. So this was the chip, flat on the desk, was these accelerometer readings. So that's normal. Hopefully these are abnormal. I think I'm about there. So let's take a look and see what Power BI was doing there. And bear with me, I'm using one hand here as I hold that chip. Should have thought this through. So here's Power BI, and I'm going to go ahead and I'm going to do a refresh on this Power BI report. So bear with me here. It's going out to that view telemetry, which is that Synapse view, and then it's going to go against the machine learning model too. So I was running this yesterday and today, so we'll look at it. You can see right now it's just showing yesterday information. Yeah, come on. So now it's going on to that. And this is probably, so I only grabbed the last 500 rows. Yay, I got an anomaly. I can put this thing down. Okay, I'll put the chip down. And what it did here is it basically said, hey, these are the accelerometer readings we got. Those aren't normal. These are normal. So under the hood, how did Power BI figure that out? Well, this is the kind of the cooking show analogy. This is, I already pulled it out of the oven. Let's go back to the kitchen counter here. So I'm going to go ahead and close out of that one. We're not going to save that one. That's that. Let's go to all the way down the bottom. There we go. So here's a Power BI report I have. I'm going to go into transform data. So this is the Power Query Editor if you've ever worked with Power BI. This was me pulling out the telemetry here. And this is basically my source, which basically states select star from, or select top 100 rows from view telemetry from that Synapse serverless database. And then I just removed some columns I thought were kind of junk. Like I don't need latitude, longitude, Fahrenheit, humidity, yada, yada, yada. All I care about is accelerometer data because that's what I've trained my model against. Within Power BI, I have this little button here that says Azure Machine Learning. So I go ahead and I click that. So now this is going out and figuring out what AKS models do I have deployed under a subscription I have access to. So what published endpoints do I have? So this is where other services can now consume your published model here. So remember before I was looking at an endpoint and I was able to throw in a couple numbers to figure out was I getting a 0 or 1. So I'm going to grab this here, and then it's just going to say, okay, these are the fields I have. I can't figure out event time. Don't ask me why we don't have date in there, but if we don't, it's a feature. So I'm going to go ahead and pick that. So these are the 6 columns that the machine learning model expects to be able to figure out good or bad. And it's no coincidence that this is the same 6 columns I'm using here in Power BI, because these 6 columns hit against this, and then the trained model can figure out an anomaly. So I go ahead and I click OK. And what I'm going to get is an extra column within Power BI here. So we can see it's running, it's doing some logic there. And so here's my extra column that says, here's the output I got from the machine learning model. And I'm going to go ahead and just expand that column because I've got columns within there. Now, it's going to give me probably, I think, about 8 columns, if I remember correctly. And the first 6 are the columns I fed it already that came from here. I don't need those 6 columns. I've already got that here in my data set because what it did is I had to feed these to say, did I get something normal or abnormal? So yeah, I could add them to the data set, but they'd be repetitive. So there's no reason for that. I just want the scored labels and the scored probabilities. So now I go ahead and I click OK. And now what it's going to do is it's going to show me, okay, here are your scored labels, here are your scored probabilities within here. And I'm going to do a refresh of my data because I think I just had data that was yesterday. How am I doing on time? I got 10 minutes. So then we should start to see some data that'll come across, like zeros and ones. And I actually did have some from yesterday. So I was actually pretty good there, that I could have used those. But now you can start to see that, okay, here's what it came across. Here's the confidence score it had that these were abnormal. Because sometimes people will look at that and go, well, if I don't have a confidence score that's higher than 80%, don't use it. It's totally up to you what you want to do there. So now I do everything I could do in Power BI, or I could rename stuff. I could, I could change the type to say, well, this is a whole number. I mean, there's everything else you want to do in Power BI, Power Query Editor, you can now do and then surface that out. But the big thing to understand here is with the designer, I was actually able to do some drag and drop, take a data set and start to build a model and then use Power BI to consume data from a data store that's giving real-time telemetry, push it against the model and get returned results. So there's some really neat stuff that you can do with there, and that's where it starts to become tangible to people. And personally, for me, fun. Maybe I just don't get out enough. I don't know. Um, let's go ahead and we'll go back into our PowerPoint here. The last thing I want to talk about is notebooks. So now we're getting into some of the advanced stuff here. So with notebooks, this is where I can write my Python. I can write my, my R. You can use the SDKs within there. So you have notebooks that are native to the machine learning workspace that look very much like a Jupyter notebook. I could use Jupyter Lab notebooks within here. I could use Visual Studio Code within here as well. So to give you another example, let's jump here. Oh, I missed it. Hold on. Here we go. So the way that I can get at my notebooks here is this is just the basic notebook functionality within machine learning. And I could have some files here that I'm looking at. So this is my get started with notebooks. And again, very much a Jupyter notebook experience that I can go ahead and run this. This is just connecting to the workspace. So the first thing I do is, if I've got the Azure ML SDK on my machine, or they're actually come on the compute pre-configured for obvious reasons. So I go ahead and I run that and it tells me, okay, I'm using ML version 1.31. It's pretty darn close to the latest. I haven't checked in the last month or two. Here's my workspace. So that's my JBender ML workspace. Then I want to see how much, what do I got for compute? So this is just saying fetch my compute resources. And then some of these other files that I can see starting to run experiments, I'm training models. These all come off of MS Learn. And we've done some workshops with customers on these so that you can go through. But you can do this yourself. You can go out to MS Learn and play with this. So again, these are notebooks within Visual Studio, or excuse me, within Azure Machine Learning Studio. If I go back to my compute, and I look at my computer, I've got a Jupyter Lab notebook link there. I can click on that. And now I'm actually running this in a Jupyter environment. So now again, just like I was looking at the notebooks that were over there, here's the same thing I had before. So if I go ahead and want to run this, I can go ahead and run this here. I can run that notebook. or I can see what it's doing. I've got to do authentication because it's the first time I've hit it. I'm not going to worry about that now because you don't need to see me jumping in. But again, this is the way that you would use the notebooks. And what this means is it's kind of like, do I know it's really you? Like, let's go to device login, put in that code, and we're going to get your credentials to make sure it's really you. So like that getting started that we were looking at is pretty much the same thing. Like I can always run this first one to say, what do I've got on the compute? But then this next one's going to ask me for, okay, do I know it's really you? I want to import the workspace. Oh, no, because I ran that earlier. That's why it showed. And then again, here I can run this one again, and it'll tell me my compute resources. So again, this is all up in the browser. Let's go to Visual Studio Code. Where is it? There it is. Is it down there? Yep, it is this one. So now we're going to go to Visual Studio Code. So if you played around with Visual Studio Code, very light, integration development environment. Here are the same notebooks. I'm connected to the compute. I'm running this locally on my machine. I don't have to have the browser open. I don't have to do the rest. So I can see there's 1.31. It'll tell me the workspace is loaded, and it'll tell me here are my compute resources that are available. And then if I want to go further, I can start to do running of experiments and do all the good stuff within there. So again, for the extensions that are running within here, what I've got is I've got the Azure Machine Learning extension, the Jupyter extension, and loaded 2 Python extensions. We've actually ran a lab where everybody did the ML learning through here, and it was a restriction based on some very tight networking of a corporate client that I had. So again, you can choose your poison here. So again, coming back to this here, do I want to do it in Visual Studio Code? Do I want to maybe do this in Jupyter Lab? Do I want to do it native? And there was even another example, like I could have done it in a local Anaconda environment if I wanted to. Anaconda can be very resource heavy, so that would probably mean I'm dimming the lights on my machine, and I want to keep as much on my machine for this presentation. So we got about 5 minutes left. The last thing I want to do is just go over some documentation. This is a big one here. Play around with this. If you found this to be interesting, we'll send you this link as well. And this is basically, you go out to Microsoft Learn and it's build AI solutions with Azure Machine Learning. So those were all the notebooks that you saw that I was doing within there. There's mastering Azure Machine Learning, automated ML. In fact, one of my colleagues, Dennis Sawyers, even wrote a book on AutoML as well. That's up on Amazon. And how do you use it? What do you do with it? Ton of documentation on machine learning as well to walk you through all of these different pieces. And then just some more information within here. And then there's a ton of samples that are out there too. And like I said, what I really like about machine learning workspace is when we were working with AutoML, we were working with the designer itself. We didn't have to write code. And that's where I think this is going to go, is you've got to be able to bring it out to the masses because there just aren't enough data scientists out there in the world to be able to do everything that people want to do these days with machine learning. So we need to get it into the hands of the data engineers as well. Tim, I have not had a chance to look at questions.
Well, we don't have a lot of questions right now, but this is like a clear case of a data engineer stepping into the fold where maybe, like you said, there's not enough data scientists, or maybe an organization doesn't have a data scientist that can allocate the time to do certain tasks. This is a clear example of where you as a database administrator, data engineer, kind of have to stretch your skills, stretch that training, open up your mind a little bit and learn ML, AutoML to be able to move these widgets around. So this has been a really good presentation. I think it opened up a lot of eyes.
All right.
Do we have any questions out there, guys? No? Okay, we got good attendance. So we had a, wait, let's see. Let's type in. With some anticipation. Oh, also, Jack, could you send me a copy of your slides, PDF? We got a comment here. Excellent example. Thanks for presenting.
Yeah.
From Angela here. Thank you, Angela.
Pleasure.
All right, guys. I'm going to stop recording. I will send out Jack's slides. I'll have the recording posted up a little bit later today. Like I said, I'm on